Dear students, my name is Sir Komel, and today I will teach you how to make the circuit of diode limiter on multisim. Let me teach you the circuit. You can see the window is sharing on your screen, and this is the circuit which is given in the question. Here it is an AC sinusoidal voltage source whose peak to peak value is 10 volt and minus 10 volt. This is the resistor of 10 kilo ohms. This is diode. Model number is 1N914. Check out the connection of the diode. Its positive terminal is connected with the ground, and its negative terminal is connected with the resistor. RL is the load resistor, which is 100 kilo ohms. So you have to plot this circuit on multi-sim software, and you have to check on oscilloscope this resultant output voltage waveform. Here you can see the negative half cycle is trimmed, but it is slightly going down minus 0.7 volt due to the voltage drop of this diode. Due to the voltage drop of silicon diode, it's going down in a negative direction, which is minus 0.7 volt. And you can see the positive half cycle is not at a fixed value of 10 volt. It is 9.09 volt. Why? Because voltage is dropping across the diode. So you have to check this waveform on the oscilloscope. Okay. Now let's start making the circuit. This is the multi-sim window. First of all, pick the AC sinusoidal source. Click on place. Then click on component. Here you will select master database, and group you will select sources. Now see the families. The first one is power sources. Second one is signal voltage sources. Press escape. Now again see the first one is power sources. Second one is signal voltage sources. In the family of power source, this is AC power. Let me select this AC power. No, this is of RMS. I have to select peak to peak AC sinusoidal voltage source. So I will delete it. Again, click on place. Click on component. The database is master database. Group is sources. Now you can click on all families option, but I will suggest you click on signal voltage sources. Now in signal voltage sources, see at the top it's AC voltage. Click on OK. and place it in the window. Now you can see it's uh, peak to peak AC sinusoidal voltage source. Double click on this. When you will double click the symbol of this peak to peak AC sinusoidal voltage source, this window will open. Here you can enter your required value. As in the circuit, it's 10 volt. So you will just put enter 10 volt. It doesn't mean need to change the frequency. Frequency is 1 kilohertz, it's fine. Click on OK. So the peak voltage is now 10 volt. Okay. Now the other component which I have to select are two resistor. One is of 10 kilo ohms and the other one is of 100 kilo ohms. Resistor can be find out from this. This is the shortcut through which you can select the basic component, or you can click on place, then you can click on component. Database is master database, group is basic. Now among the families, you will select the family of resistor, and you can see there are a lot of resistance values. Press escape. You can select any value from these one, but you have to check footprint as well. Like these are the footprints which different manufacturers have manufactured, and these are introduced into multi-sim software. I will select the first one, footprint. Selecting no footprint is a mistake. So you have to select any footprint. If it is given in the circuit, then you have to select that particular footprint. If it's not given in the circuit, then you can select as per your choice. Like I am selecting the first footprint. Now click on OK. Place resistor. Again click on OK. Place the second resistor. You can change the value of the resistor. What is the value? It's of 10 kilo ohms. It's of 10 kilo ohms. So you have to enter the value of resistor 10 kilo ohms. Double click the icon of the resistor and enter 10 kilo ohms. You can enter 10,000, or you can just enter 10K, capital K, 10 kilo ohms. The value of the load resistance is 100 kilo ohm. First of all, click left click the icon, and rotate 90-degree clockwise. Now double click and change the value, which is 100 kilo ohms. Moving the component, you can do it with the help of cursor keys. Like after selecting the component, just single click, and then if I want to move it right, I will press right cursor key on keyboard. If I want to move it towards left, then I will press the left cursor key on keyboard. For top, the top cursor key. For bottom, the bottom cursor key. Okay. Now you have to select the diode. Model number is given 1N914. First, you will check this model number is given into the library of multisim. Click on place, then click on component. Then the database is master database. Group is not basic. You have to select diodes as group. So click on diodes. Now you will type 1 and 914. 1 and 914. Yeah, it's given into the library. So you will select it and place it on the you will select it and place it on the multisim window. Single click the icon of the component, then left click and select rotate 90-degree clockwise. No. Rotate 90-degree counterclockwise. Okay. Now you have to do the connections like in the circuit are given. AC voltage source is connected with the resistor 10 kilo ohms. 10 kilo ohms is connected with the diode, then 100 kilo ohms, and these terminals are connected with the ground. We have to select the ground as well. This is the symbol of ground. Select ground. Now do the connections. How to do the connection, how the wire is made into multisim. I'm telling you this. You just have to take the cursor arrow onto the terminal. When you will put the cursor arrow onto the terminal, this symbol, this sign will occur. It's showing the wire is now is starting. So you will just click and wire is making. And where you have to end the wire, drop it. Okay, so this is the way the wire is created and dropped in multisim. Like now I am going to connect the diode. So I will put my cursor arrow onto the terminal of this diode's ground symbol. Then I will right click. The wire is starting. Then I will drop the click where I have to end this wire. This is the way the wire is created and dropped. Okay. Now the circuit is completed. In the end, I will connect an oscilloscope. To select oscilloscope, you have to look these icons on the right side bar. First one is multimeter. Second one is function generator. Third one is watt meter. Fourth one is oscilloscope. Click on oscilloscope and place it here. Okay. Now you have to see this output voltage waveform on oscilloscope. Input waveform is this peak to peak 10 volt AC sinusoidal voltage waveform. So I will connect the input to the channel A of oscilloscope and output to the channel B of oscilloscope. So on channel A you will see this waveform and on channel B you will see this waveform. This is the channel A. Channel A is connected across this AC sinusoidal voltage source which is peak to peak. So we will be able to see the 10 volt peak to peak AC sinusoidal input voltage source on channel A of the oscilloscope. Now I will connect channel B with the output. It means I will connect channel B with the load resistance 100 kilo ohms. Now on channel B I will see the output voltage waveform, which is this one. Circuit is completed. Now click on run button. Its short key is F5, so you can also press F5 simply on keyboard to start the running process sim, or you can simply click run. Now the running is started and you have to double click on oscilloscope to see the results. You have to do some settings, like first of all look at time base and decrease the scale, which is 10 milliseconds per division. I decrease it. Now it's 5 millisecond per division. I further decrease it. Now it's 1 millisecond per division. I think now it's fine. 1 millisecond per division. Now come towards channel A and decrease the scale, which is 5 volt per division. No, decreasing the scale is disturbing the shape, so I will increase it. Now you can see increasing the shape. So channel A is showing the AC sinusoidal input voltage source, input voltage signal, whose scale is 20 volt per division. Now this is channel B, which is showing the output voltage waveform. I will just set its position. Now you can see we are getting the exact shape of output voltage waveform. You can see the negative half cycle is limiting here, which is the operation of diode limiter, diode clipper, and you can see it is slightly going into the negative direction, minus 0.7 volt, which is due to the voltage drop across the diode. So on channel B, we are getting the exact shape of output voltage waveform, which is shown here in the figure. Okay, so the circuit is correct. Stop the simulation. Thank you very much.